All right, let's look at line graphs. Okay, take some critical thinking for this stuff. The first three terms of a geometric sequence are as follows. We have 3, 6, 12. So we could add 3 to get there, but you can't add 3 to get there. So let's try multiplying. 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48, 48 times 2 is 96. Don't need to show anywhere. Oh, it just says next two terms. Don't need that. A store is selling laptops for $600. So one laptop would be $600. Use the information, plot the order of pairs by the table. Let's get this up a little bit so we can see the table on the same slide. Okay, so we have my dependent and independent variable. Remember, dry mix, dry D. This is dependent. This depends on this. This is always independent. So the number of laptops is independent. So if you have 2 laptops, that would be 2 times 600, $1,200. 6 laptops, 6 times 600 is 3,600. And then 8 times 6, 8 times 6 is 48, 0, 0, 100. Okay, so now I need to plot these points. 2, 1,200. I could do 1, 600 if I wanted, but that's not on there. 6, 3,600. And then 8, 4,800. These all should be on a straight line. This should be a line. It should be linear. I could just do the outside too and check to make sure the other ones work. They should. It should go through 0, 0. Think about it. If you spend $0, you have 0 laptops. Alright. So that's a big thing we're doing this week. We're making T-charts. We need to know our independent and our dependent variables and go from there. Below is the table of functions. So this is my input, this is my output, this is my independent variable, my dependent. Put this in, get this, put this in, get this. Ooh, it looked at first like I was cutting it in half, but that's not what I'm doing. I'm subtracting 4, subtract 4, subtract 4, subtract 4. So what's 4 less than n? N minus 4. 9 minus 4, 8 minus 4, 6 minus 4. Okay, Mylan is driving on a highway. He uses 1 gallon of gas every 50 miles. Okay, so I could make a T-chart of that. Gallons, miles. So this is independent, dependent. 1 gallon, 50 miles, 2 gallons, 100 miles, 3 gallons, 150, so on and so forth. 50 miles he drives. The distance, D in miles, he travels on gallons is given here. So here's my formula. 1 times 50, 2 times 50. How far does he go on 3 gallons? So it's 3 times 50, 150 miles. Next, a gym class has yoga classes. Each class has 14 students. If there are C classes, write an equation to represent the number of students S taking yoga. Okay, so I have classes comes first, and then I have students. Okay, so 1 class would be 14, 2 classes would be 28. My marker's not working. Sorry about that, guys. 2 classes, 28. 3 classes, 42, so on and so forth. How do I do that? I'm multiplying by 14. That times 14 times 14 times 14. So it's classes times 14 gives me my students. Okay, if there are C classes, so C times 14 gives me S students. C times 14 is S. That is my equation. You could do S divided by 14 gives you a C. This one makes more sense. Either one will work for you. Remember, you can write that as C times 14. You can't write C14. You could write 14C. Flip it a little bit. Number 6, Maria earns $55 each week working a part-time job. Okay, so we're going to use A for dollars, B for books. So after 0 weeks, she doesn't make any money. After 1 week, she makes $55. Let's take the 0 out, that might confuse it a little bit. $55 each work week. She earns $1 additional for each book that she sells. Okay, let A be the amount in dollars that she earns in a week if she sells B books. So this is the amount of books. This is the amount of money. Okay, so I should go back. Sorry, I didn't understand the question fully. So if she sells 0 books, she's still gonna make money. She's still gonna make $55. She sells 1 book, she's gonna make $56. 2 books, $57. 3 books, $58. We gotta figure out how to get from here to here. We know we're not gonna multiply. Let's try adding. Let's try adding 55 each time. So B plus 55, or it makes more sense, 55 plus B is gonna give us our amount. Either of those equations works. Or you could say the amount minus B equals 55. A lot of ways to write it. So if she sells 22 books, so let's plug in 22, 55 plus 22, she's gonna make $77. All right? We can easily graph this as well. This problem doesn't ask us to yet. This is a week where I really recommend T-charts. Your homework, I'm gonna wanna see a lot of T-charts. Teresa's younger than her brother. The table shows her age in years alongside her brother's age. Using X for Teresa's age and Y for her brother's age, do the following. Plot the ordered pair, then write an equation. Okay, I'm gonna go ahead and write an equation first because I can see this relationship pretty easily. So I've got these 2 numbers. I can take any 2 of them. And I'm gonna see how they relate, okay? Those 2 relate the same way. There's a difference of 5 in there. So somehow those numbers are gonna relate to 5. Okay, so, well, I know 10 minus 5 is 5. Let's see if it works for all these. 12 minus 7 is 5. 13 minus 8 is 5. So this minus this is 5. This minus this is 5. So Y minus X equals 5. Okay. Another way we could write it is X plus 5 equals Y. That equation works just as well. There's other equations we can use too, but those 2 make the most sense. Okay, so then we graph it. I'm not going to bore you graphing that whole thing, besides the fact that you could graph any 2 points, 5, 10. 5, go over 5, up 10. Remember, we always do. Well, we got to look at what's on our axes to know which goes where. And then 11, 16. And if I graph these right, it should go through all these points. I don't have to put each dot. I could put each dot on there, but it'll work out for you. Problem 8. A plant is already 9 centimeters tall, and it will grow 1 centimeter each month. Let H be the plant's height after M months. So this here is my X, it's my independent variable. So I want to put months first on my T-chart. Always put your X-axis first, and then on the Y-axis I have H, my height. Okay, so after 0 months, the plant's already 9. After 1 month, well, it's going to grow 1 centimeter, so it's going to be 10. After 2 months, it's going to be 11. After 3 months, it's going to be 12, and so on and so forth. Okay, so I got to figure out the relationship here. This is my input, this is my output. Well, each time, looks like I'm going to add 9 to get that. So plus 9 to each of these to get that. So M plus 9 equals H. Okay, so that's one formula. You could also have H minus M equals 9. Okay, write an equation, then graph your equation using the axes below. So again, I could put in 0, 9, and I could put in 3, 12, and I know the other ones should go right through it, should go right up like that. all the way up. Okay? Make a T-chart, use 0, 1, 2, 3. Should usually work out for you. Sometimes you want to try a negative number. Sometimes you might want to try bigger than that. That's a pretty good strategy. Okay, for each situation below, identify the independent variable and the dependent variable. Layla makes necklaces for a job. The table below shows the number of hours she will work, how it influenced the number of necklaces she made. Okay, so which is the independent? Which influences the other? Well, number of hours worked. That would be what I put on my X. So that's my independent variable. That's the dependent. This depends on how much of this. The more necklaces you want, work more hours. Okay, the graph below shows the price of each car sold. Okay, again, so the car's price is dependent on the car's age. So this is independent. That's dependent on the dry mix. Independent on the X, dependent on the Y. That's my dependent, that's my independent. Okay, don't just memorize that, know that, but know what it means to be dependent and independent. Okay, last one, we gotta interpret this. The graph below shows the number of orders received by a company for 5 months. So here's the months. Here's the number of orders that they received. What was the greatest number of orders in a month? So to know the greatest number of orders, I'm gonna look for the peak, whichever one's the highest. Clearly this, January. When did the greatest decrease in orders occur? So the greatest decrease, since they're all evenly spaced, would be the one that drops the steepest, okay? So the steepest decline, these are my two declines. This one's greater. So between January and February. Greatest decrease here, January to February, so February. All right, that's your homework this week. Good luck, do your best, understand it.